We all know that the number 0.9 repeated, or 0.9999999 and so on and so forth, equals 1, and that can be proved algebraically by, I'm just going to show it to you. It can be proved algebraically by first, I'm just going to write out a couple of the 9s, and we can set up this to x, because this number is very hard to work with. X is just x, 1x, it's very simple to work with. So then we can multiply that number x by 10, because then after that, we still have infinity 9s out here, but then we have that 9 in the front. And the reason we did this was that because, well, I mean, if you think about it, this decimal part out there is the part that worries you, right? Because it's the 9 repeated part that worries about you, so we can just get rid of that repeated by doing this, because then when we subtract them, we have 9x over here, 9 minus 0 is 9, and then this very weird fractiony part all goes away, and we just have 9.0, or just 9, sorry. And then dividing by 9, we just have 9 over 9, and we have x equals 1, and because x is that 0.9 repeated, that 0.9 repeated equals 1. So I know that I could prove that very algebraically, and I did this when I was 6, and then since then, I was always pretty unsatisfied with this algebraic proof because, well, here's the thing. It's true, yes, but it doesn't make a lot of sense because you have this 0 point something, and then you didn't do anything, and then somehow it turns into 1.0. So it was always a little weird to me, and then finally, just a few days ago, I thought about this. So I want to prove this a non-algebraic way, so that will make a lot more sense to me. And what makes a lot more sense? Logic makes sense. Logic is sense. So I tried to prove this logically, and here's what I came up with. Again, it's the 9 repeated that worries us, all those 9s. So let's say we get rid of all of those 9s except 1. I'll just have 0.9. And then we wanted to get from 0.9 up to 1. Well, then, of course, you just add 0.1. It's very simple, right? So then maybe we add another 9. And then you can kind of see the pattern a little bit. So if you add in the third 9, it's really clear. I'm just going to add it in just for emphasis. 0.01 equals 1. And you can kind of see here that the number of 9s you have, so we have a whole bunch of 9s. I'm not going to go up to infinity yet. We have a whole bunch of 9s. And there's m 9s in here, okay? So there's m 9s. And then looking at this, we can see that there's m minus 1 zeros, because, well, here, we had 1 9, so then m equals 1. We have 1 minus 1, 0 zeros after the decimal point, so no zeros and then a 1, so 0.1. And here, well, we have m is 2 in this situation, so in 2 minus 1, we have 1 0 after the decimal point, and then a 1, and the same thing goes with here. So if we have this amount of 9s, and then we wanted to get up to 1, well, then we won't have to add 0.m minus 1 zeros, and then a 1 to get up to 1. So putting this in the 0.9 repeated, what that makes sense of is here, m is infinity, right? You have infinity 9s, so infinity minus 1 zeros, well, that's still infinity zeros, right? So we have 0.infinity zeros, well, that can be written as 0 repeated. So 0.0 repeated, then we have a 1. So here's the problem. If we have infinity zeros, they'll keep going on forever, and the 1 will never come, which means technically when you're writing this, you're just getting rid of the 1, so 0 difference. Like if you had 0.0 repeated, and you had a whole bunch of digits, 5, 4, 9, 3, 1, 2, or 2, 1, sorry. But because all these digits out here are after the 0 repeated, which it repeats forever, which means all these digits will never come. So we have this 0.0 repeated 1. We can just get rid of that 1. And then when we get rid of that 1, 0.0 repeated is 0. So we have to take 0.9 repeated, and then we add on 0 to get 1. Well, 0 is nothing, so then we get 0.9 repeated is 1. So I proved it logically, although there's still another problem. It's still 0.9, it's still 0 point something turned into 1 point something. I'm not satisfied.